Hello everybody, Mr. Tannen here. I'm about to throw another video at you. You better duck. Ha ha, yes. So this corresponds to 9.4, the whatchamacallit, the next section you had assigned for this week. And we'll see whether I do separate videos for 9.5 and 9.6 or just depending how it rolls, I'll maybe do it with this same video here. But what I'm going to do is show you a few things. So this section is all about graphing sine and cosine functions. So it gets into just sort of, what will the graphs of sine and cosine look like. I think the textbook does a nice job of giving you some really good visuals on page 486 and 489, and then goes through some examples, talks about shifts, translations, and then also reflections. But it can get a little funkalicious, but for the most part, I just want to go over the basics in this video and some of the terminology they're giving us. So if we're going to start with our sine function, so we could say we're going to graph y equals sine of x. Well, what I'll do here is I'll make my coordinate plane, bam, bam, and then I got my little, let me switch to purple here, it's kind of nice. So what you'll see here is if I'm thinking about my sine function, I'm going to go by units of pi. So that would make this 3 pi over 2, and this would be pi over 2. And then here we go, negative pi over 2. So I'm actually doing my units, as I said, in terms of pi, I should have said. And I hopefully will see why in a second. So the thing is, when we have a sine so my input in this is going to be the angle measure in radians, right? That's why we're doing it in terms of pi. So remember, sine, if we think about our unit circle here, is the y value, right? So at 0, the y value is also 0. So if I'm to plot my first point, I'll do it here in something nice, like an orange perhaps. It's going to start right here at the origin, right? It doesn't like me making a point for some reason. And then at 90 degrees, if we think about that, or pi over 2 radians, it's going to be up at a y value of 1, right? So actually, that's going to be the maximum. So if I look at this here, it's going to go up to 1. Then at pi over here, the sign is back to 0. Then at 3 pi over 2, it's going to be at negative 1. And then at 2 pi, it'll be back to the original starting spot, 0. And if we go just think about a negative pi over 2, well, we're also at negative 1. And maybe you're starting to see the pattern now. It's got this this cyclical nature to it. And it's going to keep repeating forever, because as we keep going around the circle, right, we just keep repeating ourselves. So there's some terms that we're going to use here when we're talking about this. And let me put some little arrows there. This is my y equals sine of x curve. And the terms we're going to use are, one is the amplitude. So the amplitude is actually this measurement. Amplitude. That's how far how high from the middle of the curve goes. So this one has an amplitude of 1. It's actually, we would say, 1/2 of the difference of the minimum and maximum value, right? So just from the middle to the top. But if we want to calculate it, we could do 2 divided by 2, right? A half of 2 to get 1. Or you could just look and see that that's 1 there. Well, we could see then that this is a function. It has another word that we use rather than repeating itself. It's periodic. So that means that the graph has a repeating pattern, simple as that. And the shortest repeating portion of the graph is called a cycle. So if we're to look here, let me grab my highlighter. This is the shortest repeating portion. Then when it gets back to that spot at 2 pi, it starts repeating itself, which makes sense because that's when we've gone around the circle once. So that is what we would call 1 period. So in this graph, our period is 2 pi. Because that's how long it takes for the graph to repeat itself. So if I erase periodic, I say the period is 2 pi. And even if you look over here, right, that's the same piece. It's still 2 pi left to right? That's the length, horizontal length along the x-axis of the period. So that's my sine function. Now let's go ahead and see what the cosine is going to look like. And there's a lot of similarities, but there's some differences. So again, I'll make my, this is just freehand here, these lines. I'm drawing them. There's no computer help. I've just been practicing my straight lines a lot during my social distancing. So we're going to use these same values. So bam. This is so nice and fun to draw these, almost as nice as bullet journaling. Drawing graphs by hand and bullet journaling, they have a lot of parallels. And then this will be 1 and this will be -1. So now let's think about if we were to graph cosine of x. Well, cosine, if we were to think about it again with the unit circle, is the x value. So at 0, it's actually 1. But then as it goes along until pi over 2, it actually now, the cosine, the x value there is 0. Then at pi, it's -1 because it's to the left. Then it's 0 again. And then we've come back at 2 pi, it's 1 again. If we think about -2 pi is this way, well, that's 0 at -pi. And again, you see it's got the exact same shape as the previous one. It's just starting at 1 rather than starting at 0. And so actually, if you were to take any sine, right, if you were to shift any cosine function or to the right pi over 2 units, you would get the exact sine graph. If you were to take any sine graph and shift it to the left pi over 2 units, you would get the same, exactly a cosine graph. And again, the amplitude of the cosine graph is the same. The amplitude is 1. And the period is also 2 pi. It's still taking the same amount of time horizontally to repeat, right? You could see it here until it gets back, or you could even think of it as this, from here to here. Well, from -pi over 2 to 3 pi over 2, that's 2 pi. It takes 2 pi on the x for it to repeat. So I hope that you enjoyed this video. The textbook shows some other ways to think about, finding the amplitude or the period, or how to find the amplitude or period if it's been stretched or shrunken, by thinking about, A times sine of bx, where b is a horizontal stretch or shrink, a is a vertical, or the same thing with cosine. I'm not as worried about that stuff as just you getting a basic understanding of this, because you'll do much more of this in pre-calc down the road. Much love.